All right, guys and gals, let's talk about the aging and development of human beings. So first, let's start with fertilization. This is when we all start. This is when that little sperm and that little egg that formed us merged together. More specifically, the nuclei of the sperm and egg fused to form a single-celled zygote. And around that single-celled zygote, we have a ring of cells that is known as the zonal polluta. This zonal polluta is made of leftover cells from the mature Graafian follicle, and is a byproduct of ovulation. So we have that membrane called the zonal polluta, and then we have that ring of cells known as the corona radiata. Both the corona radiata and the zonal polluta help the function to limit how many sperm have access to the egg. We only want one sperm getting into that secondary oocyte for fertilization purposes. So during fertilization, we're going to have several sperm penetrate the corona radiata. So several sperm will make it through this outer barrier of cells. And then those sperm will have acrosomes. These are going to be small penetrating packets that will have digestive enzymes on the apex or the tip of the sperm cell. And the acrosomal enzymes will digest part of the zonal pellucida, or part of that outer membrane of the secondary oocyte. One of those sperm is able to bind and fuse with the egg's plasma membrane. Once that happens, the sperm's nucleus will enter into the egg, and the sperm and egg nuclei fuse. And once those sperm and egg nuclei fuse together, that is fertilization. So we find that the sperm will swim through the corona radiata, or make its way through that ring of that radiating circle of cells, and then the acrosome allows it to digest the zonal pellucida, and then it penetrates the plasma membrane. And once it penetrates the plasma membrane, that egg is going, or the secondary oocyte will have vesicles full of cortical granules. These cortical granules will then be released and make it so that the zonal pellucida will prevent any other sperm from entering into the egg. So that those cortical membranes change the plasma membrane of the secondary oocyte to keep extra sperm from getting inside. The vesicles that contain those enzymes that do this come from the egg itself. The sperm cell does not contribute anything except for its genetic material. The vesicles that contain those cortical or granular enzymes are going to be stored within the secondary oocyte. After fertilization has occurred, there are going to be several different stages of development. We'll first have cleavage, and this very large single-celled zygote will divide multiple times. The cells will divide or undergo division and become smaller and smaller and smaller as they divide. As the cells are becoming smaller and smaller and smaller, the embryo eventually needs to start absorbing nutrients. And as the nutrients begin to be absorbed, then the embryo begins to increase in size. This increase in size is known as growth. After we have several rounds of cellular division and growth occur, we can have morphogenesis begin, where cells begin to specialize. And then as the specialization continues, we are going to have differentiation set in. And this is when cells are set and they are going to be moving down a very specific developmental pathway. As we look at the developing embryo, there are several structures we need to focus on. We have the precursor umbilical cord, and this umbilical cord merges with the structure known as the aleantosis. The aleantosis is the precursor of the urinary bladder. We have a yolk sac as well. This yolk sac is going to also merge, and it's separate from the umbilical cord. Our yolk sac is going to contain many blood vessels and is the formation of the very first blood cells. We also have an amnion. The amnion wraps around our fetus, around our embryo at this point. Yes, it is an embryo at this point. The amnion wraps around the embryo and contains the amniotic cavity and amniotic fluid. And then the chorion is also going to wrap around the amnion. Our chorion is part of the placenta and is on the fetal side of the placenta. We have another side of the placenta right here that is down here. This side of the placenta is not known as our chorion. During the very first week of development after fertilization, this is the pre-embryonic week. Generally speaking, 6 of those 7 days is going to be spent with the cells differentiate or cleaving or going through divisions, but not actually being implanted. Implantation is typically at 6 days after development. The second week after fertilization to the second month after fertilization, we have the embryonic stage or embryonic development. And then the 3rd through 9th months, we have fetal development. So there's not a hard and fast rule. There's a little bit of gray area between the embryonic stage and the fetal stage. What about in between the second month, what about that little fuzzy zone between the second month and the 3rd month? There is no hard and fast rule for this, so there are some arbitrary decisions made when separating the embryonic stage from the fetal stage. And then finally, the fetal stage ends at birth, when that child leaves the when that child leaves the uterus. After birth, we find that the child or the human being will go through infancy, so they're a kid, then they're a toddler, then they go through adolescence. Adolescence is when they enter puberty, and then they have adulthood. This figure was not in your textbook. I included this figure because it's kind of nice to know how we look in utero. You know, it's fun to see the baby bump and all that jazz, but what's going on the inside? At 8 weeks after fertilization, we are very tiny and look about like this. And then at 12 weeks, so at the end of the 3rd month, we are going to be a fetus, and this is when we start to look more like a human being. At 21 weeks after fertilization, that is the record for the youngest or least developed child being born and living for 1 year after birth. So we've all heard of prematurely born children. Most prematurely born children are born around 32 weeks after fertilization. But there has been a child born 21 weeks and 6 days after fertilization, or had only 21 weeks and 6 days total of gestation or development inside of the female's reproductive tract before they were born. And they lived for a year. I thought that was pretty cool. During that pre-embryonic stage, we have cleavage. So the cell is that zygote will start to divide and will form a compact ball of smaller embryonic cells known as the morula. At this stage, there is no differentiation or specialization. And if that morula splits, you can have identical twins form. After the morula the cells start to specialize within the morula, we'll have an early blastocyst. And this blastocyst is going to be essentially a hollow ball of cells. So as long as we have a compact ball of cells or a solid ball of cells, it's a morula, and once we have a hollow ball of cells form, it's called a blastocyst. And it's that blastocyst that implants in the endometrium of the woman's uterus. So here we have the secondary oocyte, here we have fertilization, now we have the egg, now we have the single-celled zygote, and now we have cleavage to form the solid ball known as the morula. And then the ball becomes hollow, it becomes a blastocyst, and that blastocyst implants inside of the endometrium. After implantation, we have pregnancy occur. Pregnancy is defined as the blastocyst implanting in the endometrium. There's a specific hormone associated with this process known as human chorionic gonadotropin, HCG, and this is the very specific hormone that we look for with pregnancy tests. HCG has a purpose. Its purpose is to maintain the corpus luteum on the ovary. And if that corpus luteum is maintained, the corpus luteum will continue secreting estrogen and progesterone that will maintain the endometrium of the uterus. During implantation, we find that inner cell mass will detach itself. So here we can see that inner cell mass of the blastocyst. And this inner cell mass will detach itself and form an embryonic disc. This embryonic disc will then differentiate and become several different layers through a process known as gastrulation. These 3 different layers are known as germ layers, and there's an ectoderm, a mesoderm, and an endoderm. And at this point in time, cells are becoming quite specialized. So 18 days after fertilization, we have a blastocyst that has implanted. It's surrounded by a chorion. We have an amniotic cavity, we have the embryonic disc, which is beginning to differentiate, and then we have the yolk sac forming. And those that embryonic disc will differentiate into 3 germ layers. We have the ectoderm, the mesoderm, and the endoderm. Our ectoderm is going to form the surface of our body, the skin. It's also going to form our nervous system. The mesoderm is going to form many of the organs in the middle of our body, so many of the organs of our abdominal pelvic cavity. And then finally, the endoderm is going to form the lining of our digestive tract and the linings of our respiratory tracts and some linings of our urinary tract as well. As we look at the embryonic development at week 3, so 3 weeks after fertilization has occurred, our nervous system is already taking place. Now keep in mind, fertilization typically occurs on day 14 of a menstrual cycle. So 3 weeks after fertilization, this is about 1 week after the woman has noticed she's had a late period. And at this point in time, the child's or the embryo's nervous system is developing. And this is when the embryo is very susceptible to alcohol poisoning, or this is when drinking alcohol is very dangerous and very risky behavior associated with children developing fetal alcohol syndrome. We also find that the heart also starts pumping at week 3, so 3 weeks after fertilization. So generally speaking, right about the time that woman has a pregnancy test to determine, oh, I'm pregnant, there are 2 things that are already going on. There's already a nervous system developing in her uterus, and there's already a heart starting to pump inside of her uterus, or developing inside of her uterus. During the 4th week, so 4 weeks after fertilization, we find that the embryo is growing larger, and it's going to be slightly larger than the height of the print in your book. So the embryo is still quite tiny. We're looking at a size of about 2 to 3 millimeters, so still pretty tiny at this point. We also have chorionic villi formed. These chorionic villi are penetrating the endometrium and beginning to remove nutrients from the mother's body, from her endometrium, and delivering those nutrients to the developing embryo. We also find that the umbilical cord forms for that developing embryo, and the precursors to our arms and legs, the limb buds, will form. Our hands and feet are also becoming apparent during the 4th week. And during the 5th week, we see that the eyes, ears, and nose are going to be noticeable. So this is about 2 to 3 weeks after the woman has noticed that she has missed her period. There are eyes and ears and noses, an eye, ear, and nose forming on that developing embryo inside of her uterus at that point in time. So this takes place very rapidly, very quickly. We have the development occurring. So here we can see earlier on at about 3 to 4 weeks, we will have that alliantosis forming. We have the yolk sac, and we have the chorion forming, and you can see the chorion is penetrating the endometrium to form chorionic villi. And then at 5 weeks, we've had an umbilical cord form, and we're having the digestive tract forming, and we are having differentiation of tissues. At week 5, this is what a human embryo looks like. It doesn't look very much like a human being at this point, but we have precursors for the arms and legs, precursors for the eyes and nose, and we have precursors for all of, or I should say many of the major organs of that we find in a typical fully grown human being. From weeks 6 to 8, so after 6 to 8 weeks after fertilization, our embryo actually starts to look like a human being. We are still in the 1st trimester at this point. We are 2 months in after fertilization. We also find that there are going to be reflexive actions occurring, and all the major organ systems have been established. And at this point, the woman is just starting to have the baby moment. She's probably also having a lot of morning sickness at this point too. The embryo is going to be about 4 centimeters or 38 millimeters wide by the end of this 8 weeks, and will weigh about the same as an aspirin tablet, so still pretty dang small at this point. Between months 3 and 4, we find after fertilization, hair starts to develop. The head will slow down and grow so that the rest of the body can catch up, and we're going to see chondral ossification occurring, so that the precursor cartilage skeleton is now starting to be replaced by compact bone and spongy bone tissue. And at this point in time, we can start to have gender determination. We can isolate a heartbeat with a stethoscope during the 4th month. after fertilization, and by the end of 4 months after fertilization, the fetus is approximately 6 inches long and weighs about 6 ounces, or a little bit over 1/3 of a pound. Between months 4, 5, and 7, so let's back up here. Months 3 and 4 mark the beginning. Month 3 marks, or this transitional stage marks the end of the first trimester and the beginning of the second trimester. Months 5 and 6 start in the second trimester, and at this point in time, the mother can typically feel the movement of the fetus inside of her uterus. The fetus is going to be curled up in the fetal position, and the fetus is capable of opening and closing the eyes, and the fetus is approximately 12 inches long, approximately a foot long, and weighs about 3 pounds. And at this point in time, if the child is prematurely born, there is a chance that the child will live. Granted, there will need to be a lot of intervention with the NICU unit. Months 8 and 9 are solidly inside of the third trimester for the child, or for the pregnancy, and this is when the child, or the fetus, is gaining weight very rapidly. The fetus is also going to rotate within the uterus, so the head is pointing down towards the cervix. If this does not occur, this is what is known as a breech pregnancy. Thankfully, this usually happens. By the end of this fetal development stage, or typically right before birth, we find that the fetus is about 7.5 pounds and 20.5 inches long. In other words, the average birth weight of a human being is 7.5 pounds, and the average birth length of a child or human being is 20.5 inches. There are some things that can be done to help minimize the risk of developing birth defects, one of which includes the mother getting physical exams from a trained doctor to help alert them to any issues and intervene before those issues become major. If mom has good health habits, good nutrition, good sleep, good exercise, she's going to have a decreased risk of birth defects in the child. Things to avoid for mom include smoking, and this is smoking tobacco or marijuana or any other chemical compound as well. Just don't smoke anything. Or also avoid using alcohol and or drugs. And these can be both legal or illegal drugs. The mother should also strongly avoid x-rays, particularly early on in the pregnancy when there's lots of rapid cell differentiation occurring. There are some very specific medications that are contraindicated with pregnancy. In other words, mom should not take this medication because she is pregnant. Also, mom should avoid sexually transmitted diseases. This means not having intercourse with anyone who has a sexually transmitted disease, or also means getting treatment for an STD if mom currently has a sexually transmitted disease while she is pregnant. Since the child is in a uterus, the child won't be able to breathe in and out using their lungs. So they need to have a different way to get, they need to have some alternative blood flow pathways to transmit oxygenated blood through their bodies. The child will receive oxygen in their blood from the placenta. The placenta is where oxygen transfer occurs. So blood is sent to the placenta through the umbilical artery. So that umbilical artery carries deoxygenated blood to the placenta, and then the umbilical vein carries oxygenated blood back from the placenta. The umbilical vein will then travel through the liver through a tube known as the ductus venosus, and then merge with the inferior vena cava. And we will mix oxygenated and deoxygenated blood at the inferior vena cava of the child while the child is in utero. And then we have partially oxygenated blood moving through the child's right atrium and right ventricle, and then getting pumped out to the lungs, where it's then sent back to the heart, and then sent out through the aorta. We find as the blood is being mixed in the child that the child will have partially oxygenated blood leaving the heart and will send fully deoxygenated blood to the placenta. In terms of development of the sex organs, we find that generally speaking, and this is in over 99% of situations, sex is just going to be based on chromosomes. XX is female, XY is male. Particularly on the Y chromosome, there's a region known as the SRY region, the sex-determining region of the Y chromosome. And this is a gene that's going to activate at week 6 and cause the embryo to develop in a male. Now, it's been found that this SRY region does not work completely in isolation. There are a few other genes that help it work on the Y chromosome, but the SRY gene is the single most important one. We also find that anti-Mullerian hormone is going to be secreted by the testicles or testes, and this hormone that's going to be secreted by the fetus causes the development of male sex traits as opposed to female sex traits or sex organs. So let's look at this figure right here. At 6 weeks after fertilization, we are by default a female. And if there is an SRY region that activates, we turn into a male. If there is no SRY region that activates, we will be funneled down that default female developmental pathway. 14 weeks after fertilization, we find that there are already primitive testicles and primitive ovaries that are developing, and the external sex organs are going to develop if dihydrotestosterone is produced by the testes. If these precursor testicles or testes secrete DHT, then male external genitalia will form. If these precursor testes do not secrete DHT, or if the tissues do not respond to DHT, female external genitalia will form. And this is on the inside or the internal anatomy. If we look at the external anatomy, at 4 weeks after fertilization, we are generic. 6 weeks after fertilization, we have a urogenital groove that is asexual or will default to the female reproductive pathway. Note that the same structure that turns into the female's clitoris will also be funneled down and turn into the glans penis of the male. There can be some abnormal development of the sex organs, though. There's the XY female syndrome. This is when an individual develops into a male because part of the Y chromosome containing the SRY develops into a female. That is a typo there. This should say into a female because that SRY region is missing from the Y chromosome. So even though they have the Y chromosome is missing that single most important gene to help you become the male. There's also XX male syndrome. This is when somebody has two X chromosomes, but one of those X chromosomes has an SRY region on it. We can also have ambiguous sex determination. This is when someone is born with ambiguous genitalia. This can be because someone didn't have enough testosterone or anti-Mullerian hormone and or dihydrotestosterone in their bodies. Sometimes there's a condition known as androgen insensitivity syndrome. And this is when all the correct hormones are made for the male developmental pathway, but the cells themselves do not have testosterone receptors on their surface or inside of their cells. And then the tissues are not going to be funneled down the developmental pathway, and by default will go back towards the female pathway. And that what person develops with female external genitalia and with very classic female characteristics, but has immature testicles inside of their abdominal pelvic cavity. This is a picture of somebody who has androgen insensitivity syndrome. They look like a female. And there's actually some nice perks to androgen insensitivity syndrome. Generally speaking, there's very little body hair, and these individuals will, generally speaking, have very classic or stereotypical good looks. They typically don't have acne as teenagers or all that excess body hair, but it's when they start to try to have kids and they are unable to have children or potentially don't have the typical menstrual cycle set in that they realize that, hey, there's something wrong with my reproductive tract, and that's when it's typically diagnosed. They can also have male pseudohermaphroditism. This happens when an individual looks like a female and then puberty sets in and anti-Mullerian hormone is produced, and at that point in time they start to get funneled partially down the male developmental pathway, but the testicles never produce testosterone or DHT, so they're never fully funneled down the female developmental pathway. I should emphasize, though, that what we're talking about on this ambiguous sex determination, while significant, is a rare occurrence. It's typically less than 1% of the population. And let's go ahead and call it quits. We just covered fertilization and implantation, And we covered sex determination. We've covered 18.1, point 2, and point 3. That's long enough for a lecture recording. If you have any questions, and yeah, this is the student version of the PowerPoint. I forgot to save the instructor version on my flash drive. I'm sorry about that, and for the lack of concept check questions. If you have any questions, though, for me about the material covered in this recording, please feel free to post them on the class discussion board, shoot me an email, or swing by my office when you're on campus. Happy studies!